Subscribe now.
Good morning, my dear children. Today is 22nd February 2025. It's morning 6 a.m. and I am here to address the CBSE 12th standard students as they have their exam, chemistry board examination on 27th February 2025. Today I'll be discussing with you the most important questions or most important topics which you have to go through to revise your entire chemistry portion. My name is Arpita Banerjee and you are watching Arpita classes. Let's get started. So, in our chemistry syllabus, the first chapter, that is solution, is from physical chemistry, which contains 7 marks. As it is a chapter of physical chemistry, you know that it has theory as well as numericals. So the theory portion which you have to prepare, or the most important questions come from the topics are the Henry's law constant and Raoult's law. You need to prepare their statements and related everything like Henry's law constant, the applications of it, the limitations of it, and Raoult's law also, the statement. Ideal and non-ideal solution. For ideal and non-ideal solution, you are going to prepare short notes so that it covers the examples, the graphs and the characteristics. Okay. Next is positive and negative deviations. You know that Raoult's law has got two limitations. One is positive deviation from the Raoult's law. One is negative deviation from the Raoult's law. So you are going to prepare everything related to this topic along with the graphs and azeotropes. So short note on azeotropes. So these are the topics you have to prepare from the theory part. From the numerical point of view, we need to prepare numerical from concentration terms. We have many concentration terms in this chapter. For example, molarity, molality, normality, mole fraction, mass by mass percentage, mass by volume percentage, volume by volume percentage. Okay, so you have to prepare numericals based on them. Then we have colligative properties. In this chapter, there are 4 colligative properties. Relative lowering of vapor pressure, elevation in boiling point, depression in freezing point and osmotic pressure. You are going to prepare numericals based on all these topics. Okay. Then we have Van 't Hoff factor. We know that for glucose or urea or cane sugar, which are non-electrolytes, for them Van 't Hoff factor I is equal to 1, and the electrolytes, for example NaCl, MgCl2, okay, for them aluminum sulfate, the Van 't Hoff factor is not equal to 1. I is not equal to 1, and for NaCl, for example, I is 2, for MgCl2 I will be 3, and so on. So numericals based on Van 't Hoff factor. Okay, so this is the entire thing which you need to prepare from solution. Let's move on to the next topic. Our next topic from physical chemistry again is electrochemistry, which contains 9 marks. From the theory part, we have to prepare the primary cell and secondary cell. Whatever cells are there in our syllabus, the reactions and uses along with construction. Okay, prepare them well. Fuel cell also. So these 3 cells, we get repeated questions in the board examination from these 3 cells. After that, we have to prepare corrosion and prevention of corrosion. So these all we are going to prepare from the theory portion. Diagram, we have to prepare galvanic cell, a well-leveled diagram we need to prepare. Many times it has been asked in the board papers. And for the numericals, we need to do numericals based on E0 cell, standard electrode potential of cell, delta G and Kc. Numericals based on these 3 topics. Then Nernst equation, we know that from Nernst equation we find out the electromotive force of a cell, that is E cell, from Nernst equation. Also the from where the entire expansion part of Nernst equation, that derivation also you need to prepare. Electrolytic cell, for electrolytic cell we'll be preparing kappa, that is conductivity, and molar conductivity, numericals based on them. Kohl-Rosch law, you also prepare the statement of Kohl-Rosch law and the numericals based on them. Alpha, that is degree of dissociation, and lambda naught m, that is molar conductivity at infinite dilution. And Faraday's law, we have 2 Faraday's law in this chapter and we have numericals based on them. So this is what you have to prepare from the electrochemistry chapter. The third chapter from physical chemistry is chemical kinetics, which again contains 7 marks. From here we need to prepare the rate of reaction, and we have to find out the rate of reaction in terms of rate of appearance of the product or rate of disappearance of the reagent, reactant I mean. You can get numericals also based on this, okay. Next you have to know what is a rate law. For a particular example like A plus B giving you product, if the rate law is R is equal to K, A to the power X into B to the power Y, we know the order is equal to X plus Y. So from here you have to prepare rate law constant, that is K, the definition of it and the order of a reaction. Then we need to know what is molecularity, which is applicable only for elementary reactions. What are elementary reactions? Which are completed in one step only. For them we can find out the molecularity, and also you find out the difference between, prepare the difference between order and molecularity, which is very frequently asked, molecularity, okay, order and molecularity. Then we have the units of rate constant. We know for zero order reaction the unit of rate constant K is mole per liter per second. For a first order reaction it is second inverse, and for a second order reaction it is mole inverse liter second inverse. So this can be asked in 1 mark MCQs or in 1 mark question. Then we have the numericals. For the numericals we'll prepare zero order integrated rate equation for a zero order reaction. We will also prepare the derivation, and also from there we'll find out the expression for T half-life period of a zero order reaction. Another thing is first order reaction, so we'll prepare the integrated rate law expression again for a first order reaction, the entire derivation you are going to do. Also from there we'll find out the T half, that is half-life period, and the graphs related to first order reaction, very important, okay. And then we have Arrhenius equation, where at two different temperatures, two different rate laws are given, and from there we mostly find out the activation energy or anything like there. You can be given the 5 quantities and one particular thing you have to find out, where T1, T2, K1, K2 and EA, these are the variables, okay. So Arrhenius equation for the rate constants at different temperature. So this is all you have to prepare for chemical kinetics. So now we come to the inorganic chemistry. The first chapter of inorganic chemistry is D and F block elements. Okay, that is the transition and inner transition elements, which contains 7 marks. From D block elements, we need to prepare all these properties, mainly especially the exceptions. Okay, very importantly they ask the give reason from the exceptions. So the property like atomic radii, oxidation state, complex formation, catalytic property, magnetic property, metallic bonding in D block elements, enthalpy of atomization, why they are very high for this type of elements, alloy and interstitial compounds, and colored ion. We know that all the D block elements form colored ion, so what is the reason behind it? All these things in theory you have to prepare very well. Then we have two compounds here, KMNO4 and K2Cr2O7. We have to prepare the preparation of both of them along with their properties. Okay, the properties means I am talking about the chemical properties. There are many chemical reactions which you need to prepare with along with their balancing part. Okay. Then we have lanthanide contraction, a very important question from A block elements. We only get this mainly, lanthanide contraction. So you prepare a short note of lanthanide contraction nicely. What is lanthanide contraction, what is the cause of it, and what are the effects of it. Okay. Then we have the differences between and the similarities between lanthanoid and actinoids. So these are all we have to prepare from D and A block elements. Okay. Now we move on to the next inorganic chemistry chapter, that is coordination compounds, that contains 7 marks. So we have to prepare the nomenclature, very important. They will ask you the IUPAC nomenclature, or they will give you the nomenclature and name, and you have to write down the compound. Then we have oxidation number. You have to find out the oxidation number of the central metal atom. Then we have coordination number again. Then ligands. What are the different types of ligands here? Unidentate ligand, bidentate, polydentate and ambidentate ligand, along with examples you need to prepare. Then we have valence bond theory, and from valence bond theory just prepare the postulates of valence bond theory, also the limitations of valence bond theory. And from this theory we are asked to find out the bonding in these compounds, that is CONH3 whole 6 3 plus, COF6 3 minus, NiCl4 2 minus, and nickel cyanide for 2 minus, tetracyanonickel 2 minus ion. So we are asked these 4 ions bonding, by valence bond theory. Then we have crystal field theory. In crystal field theory, we have this relationship, that is tetrahedral, the crystal field energy in tetrahedral complex delta T is equal to 4 by 9 delta naught delta O, that is octahedral complex. So this relationship they asked, and then the most importantly they ask you the isomerism. We have 2 types of isomerism, one is structural isomerism and one is stereoisomerism. In structural isomerism we have 4 different types, but mostly they ask you the linkage isomerism and ionization isomerism. So prepare the examples very nicely. In stereoisomerism, we have geometrical isomerism, which is cis and trans, and we have optical isomerism. Questions are asked from both the types, geometrical isomerism as well as optical isomerism. Prepare the examples very nicely. So this is what we need to prepare from coordination compounds. So after inorganic chemistry, we come to organic chemistry. Now the first chapter in organic chemistry is haloalkanes and haloarenes, which has 6 marks. So there we have to prepare all the name reaction. I will suggest you to prepare all the name reactions from all the chapters, because 80% questions they come from name reactions only. Okay. So in haloalkanes, haloarenes we have Sand-Mayer's reaction, we have Finkelstein reaction, Schwarz reaction, Wirth reaction, Fittig reaction and Wirth-Fittig reaction. Prepare all these name reactions like anything. You know the substrate, you know the reagent, you know the conditions of the reaction and the product of the reaction. You prepare it like very good, very well. Okay. Next we have nucleophilic substitution reaction for haloalkanes or haloalkanes. So the reaction with aqueous NaOH, here you know that we get alcohol, ROH we get. Then we have the reaction with KCN, here we get RCN, and then we have the reaction with AgCN where we get isocyanide, that is RNC. So this nucleophilic substitution reaction you need to prepare. Then we have SN2 and SN1 reaction. So prepare everything about it, the mechanism, taking particular example, show the mechanism for SN2, show the mechanism of SN1 and the distinction between SN1 and SN2, where you have the characteristics also. For example, SN1 reaction is a 2-step reaction, the intermediate is carbocation, it is the attack from both the sides and then you get the product with racemization. For SN2 the attack is from back side, and the degree order of the reaction also. All these things you have to prepare from SN1 and SN2. Prepare very well, you can get question like any type of question from these 2 topics. Okay. Then you have elimination reaction, where we have to prepare the rule, that is Safe rule for elimination reaction, which is also called as dehydrohalogenation, if you remember. So that reaction, and then we have the addition of HX, haloic acid in alkene, okay, which happens according to Markovnikov rule. And here we have anti-Markovnikov rule also, when the same reaction happens in presence of peroxide along with HBr. Also remember that anti-Markovnikov rule is only applicable for HBr in presence of peroxide. Okay, it's not applicable for HCl and HI. So all these topics you prepare very well from haloalkanes and haloarenes. Okay. So the next chapter is alcohol, phenol and ether. This is again a chapter from organic chemistry which contains 6 marks. Here we have 3 mechanisms. Out of these 3 mechanisms, one might come in your board paper. The mechanism is hydration of alkene, which leads to alcohol. This is one of the mechanisms. You can see there are 3 steps. Prepare them very well. Then we have dehydration of alcohol, which leads to alkene, and we have dehydration of alcohol, which leads to ether. You know that dehydration of alcohol can lead to alkene or ether depending on the temperature. Here the temperature requirement is 413 Kelvin, as much as remember, and here it is 443 Kelvin. Check the temperature nicely, and we have this 3 mechanism. Okay. Then we have, when you have Grignard reagent, when reacts with formaldehyde, we get 1 degree alcohol. Grignard reagent reacts with any aldehyde other than formaldehyde, we get 2 degree alcohol, and Grignard reagent reacts with ketone, we get 3 degree alcohol. Very, very, very important. Prepare them very nicely. Then we have oxidation of alcohols. This oxidation of alcohols can be done in presence of copper at 573 Kelvin temperature. Then you see what is happening from 1 degree alcohol, what we get, from 2 degree alcohol, what we get, and from 3 degree alcohol, what we get. Also, the oxidation can be done with specific reagent like PCC, pyridinium chlorochromate. Then what is the product? It can be done with CrO3, it can be done with KMnO4 or acidified K2Cr2O7. So do the oxidation topic very nicely. Then we have acidic strength. We have to, compare the acidic strength. We know that phenols are more acidic than alcohols. Why? What is the reason? So there we have to talk about the stability of conjugate base. Okay. So that, and then we know para-nitrophenol is more acidic than phenol. Even that topic, it can be asked in give reason. So we have to prepare that. Then we have reactions of phenols. Basically, the preparation of phenols also you prepare. I have not written it here. I will just write it down. Preparation of phenol. Prepare all the preparation of phenol very nicely, okay, and then preparation of phenol from aniline, preparation of phenol from cumene, very nicely you prepare. Then we have reactions of phenol. In this we have got many name reactions like Kolbe's reaction, Riemann-Tiemann reaction, and the reaction of phenol with concentrated HNO3 where we get picric acid, very important reaction. Then we have Williamson synthesis reaction for the preparation of ether, which is again very important. And finally, the reaction of ether with HI. These are all like you have to prepare from alcohol, phenol and ether topic. So the next chapter in organic chemistry is aldehydes, ketones and carboxylic acid, which has 8 marks. Okay, this is again a very important chapter. From aldehydes and ketones, we have to again prepare all the name reaction. We have Rosenman reaction over here. We have Stephen reaction and Itard reaction, Gattelman-Koch reaction, Clemenson reduction and Wolff-Kirchner reduction. You know that these two reductions, they give rise to alkanes. Okay, alkanes. The product is alkane. So prepare these name reactions very nicely. You are not allowed to forget anything about these name reactions. Okay. Then we have Tollens test and Fellings test and iodoform test. Tollens test and Fellings test, you know that this test distinguish between, these tests are the distinction between aldehydes and ketones, RCHO and RCOR. These are the distinction tests between the aldehydes and ketones. And iodoform test, which is shown by, methyl ketone, that is COCH3 group, wherever the COCH3 groups are present, or maybe the CHOH groups are present, they are iodoform test is shown by them. So this is also very important. Prepare the short note of iodoform test. Then we have boiling point comparison, where we know that the boiling point of carboxylic acid is maximum, and the train goes like this. RH, that is alkane, the boiling point of ether is more than that. Which is less than again aldehyde, which is less than ketone, which is less than alcohol, and finally carboxylic acid as having the maximum boiling point. So you need to know the reason behind it. Then we have very important topic like aldol condensation, Cannizzaro reaction. Prepare the short notes from there. Aldol condensation, you know that the aldehyde which are containing alpha hydrogen atom, they can go for aldol condensation, whereas in Cannizzaro there is no alpha hydrogen atom. So aldehydes or ketones which are having alpha hydrogen atom will go for aldol condensation, which are not having alpha hydrogen, they will go for Cannizzaro reaction. Prepare the short notes very nicely. Then we have nucleophilic addition with the aldehyde and ketone, where we have the addition of HCN, where we get a cyanohydrine. Okay, then we have hydroxylamine, addition of hydroxylamine, which gives rise to oxime, and then we have addition of hydrazine, which gives rise to hydrazone. Prepare these reactions very nicely. Then we have order of reaction. They can ask you, give reason why aldehydes are more reactive than ketone. So there we have to discuss that. And then in carboxylic acid, from this topic we have to prepare the acidic strength. Okay, we know that the electron donating groups, they decrease the acidity, and electron withdrawing group, they increase the acidity. So that you have to prepare nicely. Then we have decarboxylation reaction in this topic, and we have Hell-Vollard-Zelensky reaction, HVZ reaction, Hell-Vollard-Zelensky reaction. Okay, and then conversion of alkyl benzene to benzoic acid, which is normally done by KMnO4, oxidizing agent. Okay, alkyl benzenes are oxidized to benzoic acid by KMnO4. So these are the topics from aldehydes, ketones and carboxylic acid to be prepared very nicely. Now the next chapter of organic chemistry is amines. The most important question from amines is asked, that is basic strength of amines in the gaseous condition and in the aqueous condition. Prepare it very nicely. Then we have some named reaction. The first one is Gabriel thalamide reaction. Okay, then we have carbyl amine reaction. Then we have Hoffman bromamide reaction, and we have Hinsberg reagent, which is used for the distinction between 1 degree, 2 degree and 3 degree amines. Hinsberg reagent, okay, where you know that we use a benzene sulfonate chloride to distinguish the 3 different types of amines. Then we have to discuss boiling point. Why the boiling point of 1 degree amine is more than 2 degree, which is again more than 3 degree. It depends on the number of hydrogen bonds, so prepare this nicely. Then in the reaction of aniline, we have to prepare acylation of aniline. Why the acylation of aniline is done? Next is nitration. Why the nitration of aniline forms the meta product? Okay, you know that it is because of the formation of anilinium ion, which is a meta directing group. So that we have to discuss. Then why they do not give Friedel-Crafts reaction? That is also we have to prepare from aniline. Next we have benzene diazonium salt. From there we need to prepare Sandmeier reaction and coupling reaction. These are the two reactions what we have to prepare from benzene diazonium salt. So these are all you have to prepare from amines. Okay, write down the reactions and prepare. Write down everything, the name of the substrate, the reagent, the condition and the product for all the named reactions nicely. So now we come to the next organic chemistry chapter, that is biomolecules. Here we have to prepare carbohydrates very nicely. Okay, in carbohydrates, in monosaccharide we need to prepare glucose, and in glucose we have structure, we have reactions of glucose and anomers. These are the 3 topics we have to cover. Covered everything about this. Whatever is written, covered everything about these topics. Okay, then we have disaccharide. In disaccharide we have sucrose, the structure of sucrose, how the sucrose is prepared, and then why it is called as an inverted sugar, why it is called as a non-reducing sugar, all these things. Then in polysaccharide we have got 3 polysaccharide. One is starch, one is cellulose and one is glycogen. Starch, the different types of starch, that is amylose and amylopectin. You need to prepare, you need to see what are the differences between amylose and amylopectin. Then cellulose and glycogen. Why glycogen is called as animal starch? That is most frequently asked question in the board papers. Then we have proteins. In proteins you prepare the alpha and beta sheeted structure, alpha helical and beta sheeted structure. Then you prepare the fibrous and globulous protein, the differences between them, the characteristics. And then denaturation of protein, prepare a short note for denaturation of protein, which is very important. Okay, and finally we have amino acids also. In amino acid we have essential and non-essential amino acids. What are they basically? With examples you need to know. Then what is peptide bond, how the proteins are formed, I mean. Then the zwitterion, the formation of zwitterion with example. Then optically inactive amino acid, we have only one optically inactive amino acid, that is glycine. It is most frequently asked in MCQs. Then we have vitamins. There are 2 types of vitamins, fat soluble and water soluble vitamins. What are fat soluble and what are water soluble vitamins, that also you need to know. Along with the deficiency diseases, they are caused by the vitamins, lack of vitamins. Then we need to prepare nucleic acid. Then everything about the nucleoside, nucleotide, the structures and all, and then DNA, RNA, everything about DNA and RNA. So these are all from all the chapters of CBSE grade 12 chemistry which we need to prepare. Whatever topics I have written in the board, please prepare everything about them and your entire chemistry syllabus will be thoroughly revised. Thank you so much. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. Stay tuned.